All right, here we are in our third objective of our EM radiation practice. Remember, I'll read the questions, then you pause the video to think of your answer, and then unpause to find out how you did. Why aren't radio waves dangerous like X-rays? Both of them are EM waves. Go press pause while you think of it. All right. When we think of danger, it's going to be due to energy. If something has a lot of energy, like X-rays do, it's going to be dangerous for you. If something has very little energy, like radio waves, they don't. And if we look at red, it says radio waves have less energy, which would be explain why they're not dangerous. Which is not a type of electromagnetic wave. Now remember, we've seen the EM spectrum a bunch. Think of one of these that would not be on there. Press pause while you think of your answer. Hopefully you know microwaves, X-rays, and radio waves are all EM radiation, which leaves sound as not. Remember, sound can't travel through space. All EM waves can. Ooh, there's going to be some data here, and you have to figure out a pattern from it. So pause while you look over it. All right, if we look at the wavelength, it's going from 400 to 500 to 600 to 700. So they're getting bigger. So as wavelength increases, what happens to, let's look at this last column, speed. Well, speed never changes, so it's probably not going to matter about speed. What about frequency? Well, it goes from 7 to 6 to 5 to 4. So wavelength goes up while frequency goes down. And yellow says that in a fancy way. It says inverse. That means opposite. But on your quiz, it'll say opposite, I think. Between wavelength, because wavelength goes bigger from 4, 5, 6 to 7, while frequency does the opposite, going 7, 6, 5, 4, 3. So pretty tough question, I admit, but you should be good now. Where would visible light appear on the electromagnetic spectrum? So would it appear in spot 1, 2, 3, or 4? Press pause. And hopefully you remember it goes right in the middle, right in number 2. Which of these types of electromagnetic radiation has the lowest frequency? Press pause. Hopefully you remember frequency means how often. So the closer waves are, the higher the frequency, the further they're spread out. The lower, this says the lowest, and we go to this end where they're spread out. So radio is the lowest, making green our choice. Which property is constant in a vacuum? This is basically the same question as objective 2 had. Press pause so you try to remember. And we said all EM waves travel at the same speed. So speed would be our answer. Which of the following has the shortest wavelength? For this one, you'll have a picture, so I'm not too worried about this. Remember, short wavelengths are on the right side with the most energy, so it's going to be X-rays, but with a picture it makes it a lot easier. Which of these EM waves has a longer wavelength than visible light? Same question, except the opposite end, and you will also have a picture for this one. So don't worry about it. It will be infrared, but again, with a picture, it's super easy. And you should be good for your test.